Ready. Okay. According to the National Multifamily Housing Council, it was reported that almost 120 million homes were in the U.S. during the year of 2015. According to the National Association of Home Builders, the average 2,000 square foot single-family home can include up to 13,127 board feet. This is equal to about 15,000 feet of 2x4s. 15,000 feet is almost 3 miles long. That means that in a house like this, almost 3 miles of this is going into construction.
Wow.
With a magnitude of that extent, it is important that we're really considering what kind of material we're using in these homes. Typically, timber, wood, is used. It comes from forests like this. However, recently, more exploration on bamboo has been taken into account. Bamboo is one of the oldest used construction materials. However, due to the variability in the grass itself, it lacks standardization and therefore has not been used as much in America. Recently, new types of engineered bamboo, which is bamboo that is manufactured and gone through a process that increases strength and durability, has been used more and more throughout the construction industry. My research topic looked to decide the best type of engineered bamboo that is most competitive within the construction field as a replacement for timber. My name is Taylor Bethhauser. I'm a senior studying civil engineering, and today I'm going to share my research on engineered bamboo used for lightweight construction. Lightweight construction is basically a house. So I will be comparing 3 different types of materials that will be assessed in the scope of a small house. These 3 materials include laminated bamboo, bamboo scrimber, which are 2 types of engineered bamboo, and then I will be comparing those 2 to timber to show how realistic it is to replace. I will be comparing these 3 materials on 2 different criteria. This includes strength. In order to assess the strength, I will be comparing the tensile and compressive strength of each of these materials. I will then also be comparing the sustainability, since it's always important going forward in our world to focus on that. In order to quantify sustainability, I will be comparing the amount of original material used. The higher percentile, the better. You want to decrease the waste throughout the process. And then I will also be comparing the global warming impacts, which takes into account the oxygen emission and the carbon dioxide consumption rate during the growing process of these materials. And it also takes into account the total impact it has in our atmosphere. But before I go into the comparison of these 3 materials, I will be talking about why bamboo is so much more sustainable than wood material. This goes into the fact that bamboo, pictured there, is a member of the grass family. So therefore it has a higher growth rate. It actually grows 40% quicker than trees, so it can be harvested more regularly, and therefore it has a higher oxygen emission rate and a higher carbon dioxide consumption rate. It consumes 45% more carbon dioxide during its growth process than trees itself, and that combined with the fast growth rate shows awesome potential for the global warming impact it can have. However, as I mentioned earlier, bamboo itself has high variability and lacks standardization, so it makes it hard to implement because without these standardizations, such as wood already has a certain criteria of maximum tensile compressive strengths that it must have in order to be used within the housing system, and we don't want to have failure of these materials because it can endanger lives. The first material I'll be talking about is a type of engineered bamboo called laminated bamboo. Laminated bamboo is manufactured by harvesting the culms of bamboo, which are just the stalks, and then splitting it into small pieces and planing them so they're flat. And then these fibers, which are cut smaller from the bamboo pieces, are then laid in different directions. These fibers are then submersed or are glued together in different directions to form small strips. As you can see in this image, there's a bunch of smaller strips going into the larger piece of material that will be used for the construction process. The gluing is very important in this process, and it shows where the high variability is and lack of strength and both compressive and tensile. And a study at the University of Cambridge reported that the tensile strength of this laminated bamboo is reported to be 90 megapascals, whereas the compressive strength was 77 megapascals. The overall manufacturing process reported that only 30% of the inputted bamboo was left at the end in the materials. This is okay because the bamboo itself already has higher sustainability than the timber. However, it's not optimal. The next material I will be talking about is bamboo scrimber. Bamboo scrimber is also an engineered bamboo, however it is manufactured differently than laminated bamboo. In bamboo scrimber, the cones are once again harvested and stripped and planed down, but then they are stripped to their fibers and they're then fluffed. Kind of like when you have a piece of hair and you work backwards on it. This increases the volume of the fiber itself, and so then it can be coated in a resin solution, which is glue, and then all put together. The main difference between the bamboo scrimber and the laminated bamboo is that all the fiber directions lie in the same direction, whereas the laminated bamboo, they were different. And because all the fibers are coated, the gluing doesn't have as much variability. This results in a higher tensile strength and compressive strength. In the same study at the University of Cambridge, it was reported that the tensile strength was 120 megapascals and the compressive strength was 86 megapascals. And the percentile of inputted bamboo that was used was 80%, which is significantly higher than the laminated bamboo. Finally, I will be talking about timber. Timber also has to go through a manufacturing process, but it's not in the same extent as the engineered bamboo. When it's taken down from the trees, it is similarly processed like the laminated bamboo, where it is stripped and planed and then glued together to create the bigger boards that are used in construction. The tensile strength of timber, which is easier to find because of the standardization and the tests that are already reported with a certain criteria they need to meet, is typically 54 megapascals, and the compressive is 46 megapascals. This is significantly smaller than the engineered bamboo. Like I said, this is standardized. It's easier to see in the ASTM book. There are chapters on how to go over this, whereas that's where engineered bamboo falls behind. This graph right here compares all the tensile and compressive strengths of the different materials. As you can see, bamboo scrimber surpasses both of its competitors for the tensile and compressive strength, and therefore it dominates that criteria. In my decision matrix I created, I listed the 3 different criteria I compared and ranked each material on a scale of 1 to 5, 5 being the highest. As the graph showed, bamboo scrimber tops both the compressive and tensile strength. It also, since its inputted material value is the highest percentile, it beats laminated bamboo, and both engineered bamboos beats timber in sustainability because of bamboo's high growth rate and carbon dioxide consumption and oxygen emission rate during the growth phase. Therefore, my final recommendation is bamboo scrimber. It has the highest strength values and global warming potential, which makes it a top competitor within the construction industry for lightweight building. Going forward, we need to establish more standardized criteria and tests, and potentially even add a chapter to the ASTM about engineered bamboo. It is something that can't be ignored any longer, and it needs to become more of a popular and more widespread use material to be used during the housing construction. And maybe 10, 20 years down the road, if you're constructing a house of your own, you'll consider bamboo scrimber as your material. And with that, I'll open the floor to questions.